Good evening, students of Class 11. We have completed Chapter 1 of Class 11. This is Dhanu Saraiya, continuing with the Chapter 2 of Class 11. Now, what is the name of this chapter? Is Motion in a Straight Line. Okay, now let us understand the name of the chapter itself in the beginning. Motion in a straight line. That means we are trying to understand how will a body move on a straight line or in a straight line. Now, what is the meaning of motion first of all? In the terms of physics, you know motion is moving from here to there. What am I doing? I am here and then I am going here and then I am going here. I am moving my position with time, and that's why I am in motion. That is, a body will be considered to be in motion if its position will change with respect to time. So what should change? Position should change. So now let us talk about position. How can I determine the position of a body? Can I say I am here, I am there? Just by saying I am here and I am there, can I or can you identify where am I? So to write down the position of a body, I require the first thing is the reference point, and the next is a rectangular coordinate system. Okay, so what is this reference point and what is this rectangular coordinate system? Let us consider a rectangular coordinate system which consists of three axes x, y and z. Okay, and the axes are perpendicular to each other, x, y and z are perpendicular to each other, and they meet at the point O, which is called as the origin and which can be considered as the reference point as we want it. And what is the rectangular coordinate system? A combination of x, y and z axis which are mutually perpendicular to each other. Fine. So now with the help of the origin and the coordinate system which is rectangular, I can determine the position of the body with time. Now for time, what do I want? I want a clock with this coordinate system to determine the time as it goes. So if I consider a coordinate system with the clock, then I will get frame of reference. What do I get? This complete arrangement is what? Frame of reference or reference frame. Simple. Frame of reference or reference frame I can say when I have a rectangular coordinate system with a clock. Now here I have three axes, means even if there is a change in coordinates of one of the axes x, y and z, we can say they are the coordinates of the axis x, y and z. This is x coordinate, this is y coordinate, this is z coordinate. Correct? So these are the coordinates of x, y and z. If there is a small change in any one coordinate, that is the x coordinate, then we say that The motion is one-dimensional. If there is a change in two coordinates we write here. This is the x coordinate, this is the y coordinate, this you have learned. Okay. So if there is change in two, or we have considered two coordinates x and y, then this particular motion is two-dimensional motion. Okay. Now here if I have three dimensions or three coordinates, then this is a three-dimensional motion. Three-dimensional motion. Okay. So to determine the position of a body, I require a coordinate system which is one-dimensional or two-dimensional or three-dimensional. Along with that, I need a time, a clock. Then it becomes a frame of reference. And then if we say that there is a change in one coordinate or two coordinate or three coordinates, then the position of the body has changed with respect to time and the body is in motion. So this is the description of a position to be determined of a given body. Okay, so I'll just move and you take a screenshot of what we have talked about position. Then in the same video, in the next page, we shall talk about path length. Now what is path length? The body has shifted its position from one point to another point. Then we have to determine its path length, or we have to determine its distance. That is what in the next page of this video only. So continue to watch our video. Okay, I just move, you take a screenshot. Now let us go to the next page where we want to describe the path length, or simply we want to understand the distance covered by a body. For that, I have considered a number line on the x-axis as you can see here. Let us consider the positions of the body or the object at the point O, which is the origin. This side of the origin, which is negative x-axis, or that side of the origin, that is the positive x-axis, which we have considered the position Q and P. Now, let us consider a car or a bus or any other object traveling from O to P. Okay. Now, from O to P, we can consider the body to move from 0 to 360 meters. So, we can write distance OP is 360 minus 0, that is simply 360 meters. This is the distance covered by the body in consideration. This distance is called the path length of the object. Now let us consider the body to move from O to P and then in the reverse direction again from P to Q. Correct? Okay. So now let us consider from O to P to Q. So what should we calculate to find out the path length? OP plus PQ, which is equal to, what is OP? We just now calculated 360 minus 0, that is 360, and from P to Q, It is 360 minus 240. What is my answer? 360 plus 120. So what is my answer? 480 meters. Remember to write the unit. So the path length of the body from O to P and P to Q is 480 meters. Fine. Okay. So when I calculate the path length of a body, I must calculate the distance travelled by the body in parts from one point to the another. All the distance should be calculated, that is from O to P and P to Q. Further, if the body is travelling from Q to O, then again I have to add Q to O, 240 minus 0. That is how much 240 I have to add. So what is my answer here? 720 meters is the total distance travelled by the body from O to P and P to Q and Q back to O. It can even go further to R, then I add another 120. So I have to keep adding the distance travelled by the body from one point to another, even if it is going back on the same path. Irrespective of whether in the positive x direction or the negative x direction, I only have to calculate that path distance and add up. That is the path length. Now, if I want to calculate the displacement, then I have to consider only 2 points. That is the initial and the final point of the travel. That's it. So displacement is a vector quantity. What should I consider? Only the initial and the final points. Okay, to make it easy, let us consider delta x, which is the displacement, is xf minus xi. In the textbook it is written x2 minus x1. I have written xf minus xi to make you understand. Xf is the final position of the body. Final position of the body. Xi is the initial position of the body. I just have to pick up these 2 points and subtract them. That is my work. And I also have to consider direction once I get the answer. The path followed in going from the initial to the final position does not matter. I can go from the initial position to the final position in any zigzag manner also. Whereas in the path length, I have to calculate each and every straight motion of the body, straight line. From O to P, P to Q, it should be a straight line, then only I can calculate the distance. Whereas in the displacement, I only have to consider initial and the final position of the body, irrespective of the path followed from initial to the final position of the body. Fine? Okay, so now let us consider an example to find out the displacement of O to P again. So O to P displacement, let us put it as delta x. What is its final, what is O to P I am writing. So what is its initial position? 0. What is its final position? P, 360. So what is my answer? 360 minus 0. 360 meters from O to P. Agreed? Which is same as the path length 360 meters from O to P. Correct? Now, let us go to the second example which I have considered here. This I am taking the same example so that you understand the difference. Now here we considered the first example. Here we considered the second example. Here again we considered the third example. So let us go like that even in displacement. Where this we can consider the first example. This is our first formula of this chapter. Xf minus xi is the formula for the displacement of the body. Final position minus initial position irrespective of the path followed between them. Fine? Okay. So now let us go to the second position. What is second example? What is the second example? The body is going from O to P to Q. Correct? Now body is started from O and it has ended to Q. So what is its xi? 0. What is its xf? What is its final position? Q. So what is Q? Q is 240. So what is my answer here? Delta x, xf minus xi, which is equal to 240 minus 0, which is 240 meters. Now, this is the displacement's answer for the path O to P to Q. And this is the answer for distance from O to P to Q. Is it the same? No. Why? Because here I have considered each and every distance O to P, P to Q. And here I have considered only the initial and the final position and subtracted them. That is the difference. Okay. Now let us go to the example number 3. What was my example number 3? I went from O to P, P to Q and Q to 0. Now that means the final position is Q. So I am going from O to P, P to Q and then back to O. So what is my delta x in this case? What is my initial position? 0. Origin 0. Final position is also 0. Origin O. Okay. So what is my initial position? 0. Final position 0. This is xf minus xi. So what is my answer? 0. Now what was this answer of the path length? Was it 0? From O to P, P to Q, Q to 0. The answer was 720 meters. Is the same answer for the displacement from O to P, P to Q, Q to 0? The answer is 0. 0 meters. Why? What is the reason? Because in this case, xi is equal to xf. And I am subtracting it, so answer will be 0. So, remember this. If you are asked with displacement and if xi and xf are same, then the displacement is 0. Agreed? So, displacement can be 0. Okay? So, what is it? Displacement can be 0. Can distance or path length be 0? Never. I am going from here to here and again from here to here. So, I have traveled the distance. Definitely. So, the path length can never be 0. Agreed? Displacement can be 0. Path length can never be 0. Okay? I hope you are understanding what I am trying to say. Okay. Now, in the case of path length, I only have to subtract and add the distance traveled. So my answer will never be negative. But in displacement, the answer can be negative or positive. If I'm going in the negative x direction, my answer will be negative. Now here, if xf is greater than xi, xf greater than xi, then delta x is positive. Okay? If the final position is less than the initial position, then delta x is negative. This also you have to remember. So if the final position is greater than the initial position, delta x will be positive. If final position is less than the initial position, delta x will be negative. Now in all these examples, whether here or here or here, they are both equal, we have xf greater than xi. That's why we got the displacement as a positive answer. Now let us consider an example in which we get the negative displacement, that is xf is less than xi. So let us consider in this case the motion of the body from P to Q. Our P is the initial position, so xi is equal to 360 meters. And Q is the final position, so 240 meters. So displacement delta x is equal to, this is our xf. Okay. So what is it? What is xf? 240 minus 360. What is our answer? Our answer of delta x is negative 360 is greater than 240 as mentioned here. Final position is less than initial position as mentioned here. So I will get a negative answer. It is negative 120 meters. Fine. So I have got a negative answer for delta x when xf is less than xi. Agreed? Okay. So this negative symbol indicates the displacement direction is in the negative x direction. Remember that. Okay. Similarly, we can even go from O to R. O to R. So what should I do for O to R? What is my delta x? My delta x is final position minus initial position. What is my final position? Negative 120 minus initial position 0. So what is my answer? Negative 120 meter. This I have just taken an example so that we can even go to the negative x direction. So what have I got? My answer? My answer is negative 120 meter. What does it mean? That the body has gone from the origin in the negative x direction. How many meters? 120 meters. So displacement will be with a direction. It is a vector quantity. Understood? Distance will always be a positive answer because it is a scalar quantity. Clear? Two more points you have to remember which we have discussed, that displacement can be 0 but distance can never be 0. These are the points which you have to remember. Okay. So I just move from here and you take a pic of what we have done just now so that you can remember it and learn it later on. Okay.